Today we're going to talk about systems of equations. By the end of this video, you should be able to solve nonlinear systems of equations by substitution and elimination. Before we get started, let's look at some prerequisite skills. First, we are going to solve a linear system by elimination and substitution, just like you did in Algebra 1. First, let's take a look at elimination. One way to solve this problem is by trying to get the x's or y's to cancel out. I'm going to cancel out the x's. So I have negative 4x in the second equation. I need to make the first equation have 4x. So I'm going to multiply the entire equation by 2. So if I distribute 2 to every term, I end up with 4x plus 2y equals 10. Then I'm going to go ahead and bring over that second equation. And now I'm going to add these two equations together. So when I add them together, the 4x and the negative 4x will cancel out. Then I have 2y plus 6y, which is 8y, equals 8. So y equals 1. When solving a system, you need to make sure you solve for both x and y. So now I'm going to go back and solve for x. I can choose either equation. I'm going to pick the first one because I think it is simpler than the second one. Then I'm going to plug 1 in for y, and then just solve for x. So I have 2x equals 4, and x equals 2. So this means that my solution would be the point 2, 1. And this is elimination. If I solve this system by substitution, I first need to take one equation and solve it for either x or y. I think it is easiest to take the first equation and solve for y. So if I have the first equation, I subtract 2x from both sides. I end up with y equals 5 minus 2x. Now I'm going to take that and plug it into the second equation. So for my second equation, I have negative 4x plus 6y, and instead of y, I'm going to put 5 minus 2x equals negative 2. Then I just need to solve for x. So if I distribute, combine like terms, and solve, I end up with x equals 2. Again, I need to go back and solve for the other variable. So I'm going to plug 2 in for x in this equation to figure out what y is. So if I know that y is 5 minus 2x, and I plug 2 in for x, I end up with y equals 1. So again, my final answer is the point 2, 1. And this is substitution. Both methods will get you the same answer. Sometimes one method is easier to do than the other one. It just depends on the problem. The other thing we need to know before we can solve systems of equations is how to factor. I'm going to show you two different methods for factoring. You can use whichever of these methods you prefer, or if there's another method that you know that works, you can use that as well. So we need to solve 3x squared equals 6 minus 7x by factoring. First of all, regardless of the method I use, I need to start by rearranging the terms so that this is equal to 0. So I have 3x squared. If I add 7x to both sides and subtract 6 from both sides. Now the first method I'm going to show you is called factoring by grouping. When you factor by grouping, you need to multiply a and c together. You get negative 18. Then you need to find two numbers that multiply to negative 18 and add up to, in this case, 7. So that would be 9 and negative 2. So now I'm going to take my original quadratic and I'm going to split the middle term. Instead of having 7x, I'm going to have 9x and negative 2x. Then I want to group my terms, and I want to factor out the greatest common factor from each set of parentheses. So for the first set of parentheses, that would be 3x, and then I'm left with x plus 3. For the second set of parentheses, that would be negative 2, and I'm left with x plus 3. If you choose to factor by grouping, you should always end up with the same expression in the parentheses after you have factored out the GCFs. If not, you made a mistake. Now I am essentially factoring the GCF from the first and second terms, so the thing that those terms have in common is x plus 3. So if I factor out an x plus 3, I'm left with. Now to finish solving, I need to set each factor equal to 0 and solve. So I end up with x equals negative 3 and x equals 2/3. And those are my two solutions. The next method I'm going to show you is trial and error or guess and check. When the numbers in the equation are fairly small and don't have very many factors, I think that trial and error is easier and faster. If you have some large numbers and it's hard to figure out what the factors of those numbers are, then factoring by grouping might be faster. So again, I need to start by setting my equation equal to 0, like I did in the first version. So then for trial and error, you want to look at what are the factors of the first term. In this case, factors of 3 are just 1 and 3. So you know that when you write out your factors, you have to have 1x and 3x in the beginning terms of each set of parentheses. So I'm going to go ahead and put those there. Then you need to look at the last term and see what its factors are. Factors of 6 are 2 and 3 and 1 and 6. Since this is a negative 6, we know that one number will be negative and one number will be positive. So now we need to do trial and error to figure out which set of numbers it's going to be, where those numbers go, and which one will be positive or negative to make our factors work. So I'm going to start by just guessing 2 and 3. So if I put a 2 here and a 3 here, then you need to do a little bit of mental math. Now, when we multiply these two factors together, we would have to multiply the 2 and the x, which would give us 2x, and multiply the 3x and the 3, which would give us 9x. Well, we know that when we add these terms together, we need them to equal positive 7x, which means we need this to be a positive 9x and a negative 2x. So that means that this 2 would have to be negative and the 3 would have to be positive. So those would be our factors. And then we have to set the factors equal to 0 and solve just like we did in the first version. So we would end up with x equals 2/3 and x equals negative 3. These are just two of the many methods that can be used to factor quadratics. Personally, I prefer one of these two methods, but if you know another method and you prefer to use that, that's totally fine.